So let's talk about the critical value in this problem. So the mean age when smokers first start is 13 years old with a population standard deviation of 1.9 years. A researcher thinks that the smoking age has significantly changed since the invention of ENDS. A survey of smokers of this generation was done to see if the mean age has changed. A sample of 31 smokers found their mean age was 12.3 years old. Do the data support the claim at the 5% level? So this problem is tricky because the problem actually wants us to use a normal distribution, although we have been told to do the student t distribution, and it's hard to know which one to do in a given situation. Here, the general rule of thumb is you want to use you can always use a t distribution, but you want to use a normal distribution only if we're dealing with a relatively large sample, right? And we would have to do that test for normality too. Our sample is 31, which is bigger than 30, and that's our relatively large idea. So the problem tells us here our test statistic is going to be z, so we're going to be using a normal distribution. So our critical values we're going to use with the inverse normal instead. So let me pull my sheets calculator over here. It's the 5% significance level, right? And it's a two-tailed test, right? You have that here. So if we do a two-tailed test, that means the area to the left is not 5%, but 0.025%, or half of 5%, right? It's 2.5%. Yep, and we get negative 1.96, which you might recognize from all those confidence intervals we made. If we do the same thing with the inverse student t, the area to the left, 2.5, right? And our degrees of freedom is 30 because it's one less than the sample size. We do get the value that you were supposing here. So it's it's not you. It's the problem. The problem wants us to use a normal distribution, and maybe that's like actually a student t distribution would make more sense in this case, I think, because it gives us a more accurate probability. Yeah. So anyway, if you have any other questions on that, let me know. That's it.